This is Amir Garanovic with Offshore Engineer TV, here today with Pierre Gazull from Tronics Microsystems to discuss MEMS inertial sensors designed for precise downhole navigation in extreme environments and the launch of their new high-temperature accelerometer. Pierre, to start us off, can you discuss your position and responsibilities with Tronics Microsystems, as well as an overview of the company and its offer to the global offshore energy market?
Well, thank you, Amir, for giving me the opportunity to talk about Tronics Microsystems and what the company offers for the energy market. My name is Pierre. I'm in charge of product marketing for Tronics high-performance MEMS inertial sensors product line, which actually includes both MEMS accelerometers and gyroscopes. So Tronics Microsystems is a company which is based in France and which is recognized as a leading provider of microelectromechanical system and especially inertial sensors for precise motion sensing, positioning, navigation, and condition monitoring of critical assets in transportation, energy, and industrial markets. So the company was founded 30 years ago. At that time, it pioneered the manufacturing of MEMS systems. And in 2016, it was acquired by the TDK Group, which is a global leader in the electronics industry with a vast portfolio of sensor, passive components, batteries, and so on. So when it comes to the energy market, this is definitely a key focus for us. We do offer a comprehensive portfolio of inertial sensors, which are used for advanced drilling technologies and which provide a very high level of accuracy and reliability to our customers.
Your high-temperature MEMS accelerometers, such as the AXO315 T0 and the new AXO315 T1, are designed for extreme environments in oil and gas drilling. How do these innovations shift the performance expectations for downhole navigation and measurement while drilling tools?
So you're right, Amir. These two sensors are intended to be embedded in measurement while drilling tools, which are tools that are used for the creation of unconventional wells with very complex trajectories. And more precisely, these two devices, these two accelerometers, they are used to measure the inclination of the drilling tool, and they have to demonstrate very high accuracy, especially in terms of, let's say, vibration and temperature condition, because that's what the tool is facing during drilling. So far for that kind of application, the quartz accelerometers were the gold standard to measure the inclination. So these quartz sensors, they are known to be very accurate. However, they are a bit bulky. They are not so small. And their integration into, let's say, the new generation of digital-centric tools can be a challenge in terms of system complexity. And last but not least, the price point of quartz accelerometers is quite high. So their usage is limited to premium application and premium solution, I would say. And with these two new devices, so the AXO315 T0 and T1, we offer a digital, cost-effective, and low swap alternative to these quartz accelerometers for directional drilling application with no compromise on performance.
Tronics closed-loop MEMS architecture claims to offer significantly better vibration rejection and bias stability than traditional open-loop or quartz accelerometers. Can you explain how this architecture actually works and why it matters for energy applications?
Sure. That's a key point in our product, so it's important to highlight this. So traditionally, the MEMS accelerometers that have been used for drilling application, they only operate with what we call open loop architecture. So this is very good for maximizing the resolution of the measurement. However, the response of that kind of device when they are exposed to high vibration is highly degraded because they actually struggle to separate the real useful signal, which is the inclination of the system, and the vibration itself, the vibration that the sensor is sensing. So they are all mixed, and at the end of the day, you lose the useful information at sensor level. So Tronics sensors leverage something which is unique to our products, which is what we call the closed loop architecture, which guarantees very high level of accuracy, very high level of linearity, even in the presence of high vibration, which is always the case when you drill downhole. Just to let you know that the error which is caused by vibration is typically 10 times lower with our solutions compared to what's currently existing on the market based on open loop solution. So in terms of application, the usage of open loop sensors is really limited to static measurement. You basically have to make some successive start and stop of the system to avoid the vibration during data acquisition. With our accelerometers, we enable a real measurement while drilling with a measurement inclination, which is continuously done, even in the presence of high vibration. And we do that with a specific electronic circuit, which is embedded in the sensor and which actually controls the displacement of the sensitive element and makes it more robust when it comes to surviving vibrations.
You mentioned like this is much more, how would I call it, cost effective than traditional quartz loop systems. Can I
Yeah.
ask you like how is that achieved?
So MEMS manufacturing is taking advantage of the manufacturing methodology of the microelectronics industry. So they are manufactured by batch on wafers, silicon wafers. So with only one batch, you can manufacture hundreds of sensors in only one batch, compared to quartz, where it's more like piece by piece. It's not volume fabrication. So this is mostly the way that the cost is reduced compared to quartz.
With AXO315 T1 extending operation up to 175 degrees Celsius, what are the main technical challenges you had to overcome to achieve reliable long-term performance in such harsh conditions?
For our customers, the key added value of these products is the capability to operate for long period of time under high level of vibration. We talked about that, and extreme temperature levels. So we already had some success stories with different applications like aerospace and transportation. So we started with all the ingredients which made the success of this AXO product family for this avionics and transportation applications. So we use the ceramic package, which is extremely good when it comes to thermal and mechanical behavior. We use a high performance MEMS element, which is manufactured here in our clean room in France. And we also used the closed loop electronic circuit that we discussed before. And we put that together, but that was good for aerospace, but that was not enough for the energy market. So we had to go through an extensive qualification campaign on several hundreds of devices to make sure that the performance of the sensor was okay for oil and gas application and can remain stable in any conditions. So this includes very aggressive thermal cycling protocols, high spectrum vibration test with vibration amplitude up to 20 G and even more. Startup test, both in cold and hot condition to make sure that the sensors can be triggered at any time, as well as accelerated aging at high temperature to make sure we can guarantee the operating lifetime of more than 1,000 hours.
Given the competitive MEMS landscape, what differentiates Tronics Microsystems offering?
So there are several players on the MEMS market, and especially on the high performance market, but I would say that Tronics is the only company on the high performance MEMS market which is able to put together a very high level of performance, mostly due to the closed loop architecture that we discussed, plus a digital architecture into a very miniature package. This is that small. I don't know if you see it on the camera, but it's very, very small. And that kind of package is perfectly fitted for application that have constrained form factors. And that's the case in the energy application, because you need to fit in downhole tools which are very, very small diameters. So the space is very limited. So the solution needs to be very small. So we are the only one on the market having this approach. And regarding the accuracy, once again, other sensors exist, but their usage is limited to static only. We are the only one on the market with, I would say, the quartz-like performance, but with the low size, low weight, and low power figures with a much more competitive price point.
Aside from oil and gas, which other energy sectors like geothermal, carbon capture, or subsea installations do you see as key growth markets for Tronics advanced inertial sensors?
So I would say geothermal is expected to witness a significant growth in the coming years, especially because there are large investments which are being done by several countries and also energy companies, which are transitioning their business model to, I would say, more sustainable energy sources. However, if you want to make geothermal profitable and maximize the yield of the production, you need to drill to temperature conditions which are sometimes more stringent, than the ones for oil exploitation, like 200 degrees C, and even more sometimes up to 300 degrees C. So from a technical standpoint, it means you will have to rely on a set of electronic devices, including sensors, which are able to operate at very high temperature points for a very long period of time. So we are currently working on quantify precisely what the business will be for geothermal and what kind of sensors will be required for geothermal drilling jobs. But there is no doubt that will be a significant vector of growth for our products in the next years.
In addition to the new high temperature accelerometer that you recently launched, can you share some information on your future products and technology roadmap serving the energy market?
Sure. So we talked about directional drilling. So you need accelerometers for directional drilling. They are used to measure the inclination, as we say, but that's actually not enough. If you want to build a complete system for drilling guidance, you also need to measure something we call the azimuth. Azimuth, the functionality behind is called north seeking or sometimes north finding. It's actually used to know where a system is pointed at with respect to the true north. It's like a compass. Actually, you can see it as a compass. So historically, north finding solutions and north seeking solution in the energy market was implemented with mechanical gyros, something we call mechanical gyros, which are extremely precise, but they are very fragile, and last but not least, they are very, very, very expensive. So there is an alternative to that, which is the use of magnetometers. So magnetometers can give very accurate measurement of the magnetic north. However, when you drill underground, there are a lot of metallic materials around, and the accuracy of the magnetometers can be highly impacted by the metallic environment, which translates into degraded performance. So there are some MEMS solution, obviously, to try to recover that situation. And Tronics is currently working on a new generation of MEMS gyroscope with extremely high level of resolution. And this gyroscope is actually able to sense the rotation of the Earth, which is very, very small, is 4 millidegree per second, so very, very small amount of data. And sensing the rotation of the Earth allows to measure the azimuth of a system with an accuracy of less than 1 degree, which is what our customers need. So this new MEMS gyroscope will start pre-production phase in mid-2026. It's currently being used for prototyping by several lead customers for their next generation directional modules. And so far, we received excellent feedback from the field, and we expect this new sensor to become the cornerstone of our product portfolio for the energy market.